Graph of sine. Given a function, there are two ways to graph its inverse. First, take A, B points from F and plot them as B, A points on F inverse. Or, second, rotate the graph of F about the line y is equal to x. We will begin this discussion by finding the inverse of the sine function. This is the graph of f of x is equal to sine x. In order for a function f of x to have an inverse, its graph must be 1 to 1. This can be verified by applying the horizontal line test or HLT. A horizontal line intersects the graph at most once. Clearly, the graph of sine x fails this test. So, how do we define the inverse of sine x? Easily,
we merely restrict the domain of sine x to the interval
minus pi by 2 less than or equal to x less than or equal to pi by 2. On this interval, the graph does pass the HLT, yet keeps its full range minus 1, 1. Thus, sine inverse x or arc sine x exists. This is not the graph of sine inverse x. It is merely the part of the sine x function that is used to graph the inverse sine function. Let's now discuss some of the properties of arc sine x. First, sine inverse x or arc sine x reverses sine x. That is, if sine pi by 2 is equal to 1, then sine inverse 1 or arc sine 1 is equal to pi by 2. This is true for inverse functions in general. That is, if f of a is equal to b, then f inverse of b is equal to a. Similarly, since sine minus pi by 6 is equal to minus 1 by 2, then arc sine minus 1 by 2 is equal to minus pi by 6.
For more such videos, download the iPrep app now.